Hello there. In today's lecture, we will talk about something we use every day but might not fully understand, the internet. If you've ever wondered what it is or how it works, don't worry. In this session, we'll keep it simple and relatable. Imagine the internet as a giant web that connects people, devices, and information all around the world. It's like a massive digital highway where data travels back and forth. For example, when you send a message, watch a video, or search for something online, that information travels through this highway to reach you instantly. The internet is essentially a network of computers and servers linked together, sharing data so you can access it anytime and from anywhere. Let's make this more relatable. Think of the internet like a postal system. Websites and apps are like stores or homes you want to visit. Your device, whether it's a phone or computer, is like the mailbox. And the internet acts like the roads and delivery trucks, carrying information from one place to another in just seconds. So when you type a question into Google, the internet quickly finds the answer from a server, a kind of supercomputer, and sends it back to your screen. The internet is dynamic, ever-growing, and it changes how we live, learn, and connect. It's not just technology, it's a part of our culture, our daily life, and our future. So next time you're surfing the web or posting on social media, remember you're engaging with a marvel of human ingenuity that connects us all. If you're learning to program, understanding the internet's mechanics will help you grasp how your code interacts with the web. So let's break it down step by step. We already know internet is a global network of computers that communicate with each other. Think of it as a massive web connecting billions of devices, from laptops to smartphones to servers. But here's the key. These devices don't just magically talk to each other. They follow rules or protocols to exchange data. These protocols make up the backbone of the internet. The role of IP addresses. To understand communication on the internet, imagine each device as a house in a giant city. Just like houses have addresses, every device on the internet has an IP address, a unique string of numbers, like 192.168.1.1. When you type a web address, like www.google.com, your device doesn't understand that name directly. Instead, it uses a system called DNS, Domain Name System, to translate the web address into an IP address. Think of DNS as the internet's phone book. For example, you type www.google.com into your browser. DNS looks up Google's IP address, like 142.250.190.78. Now your device knows where to send the request. How data travels next? Let's see how data moves from one device to another. The internet uses a method called packet switching. Here's how it works. When you request something, like a web page, your device breaks the data into small pieces called packets. These packets travel independently across the internet using the most efficient routes available. Once they reach their destination, the receiving device reassembles the packets into the original data. Think of it like mailing a puzzle. Each piece might take a different route, but they all arrive and are put back together. The role of protocols, HTTP and TCP/IP, two critical protocols make this communication possible. TCP/IP, Transmission Control Protocol Internet Protocol, ensures that packets are sent, received, and reassembled correctly. TCP also checks for errors and resends any missing packets. HTTP, Hypertext Transfer Protocol, is what web browsers use to fetch and display web pages. When you load a web page, your browser sends an HTTP request to the web server asking for the page. The server responds with an HTTP response, sending back the HTML, CSS, and JavaScript files. Your browser processes these files and displays the page on your screen. Servers and clients. Let's talk about the relationship between clients and servers. A client is your device, like a computer or phone, that requests information. A server is a powerful computer that stores and sends the requested information. For example, when you log into a social media app, your phone, the client, sends a request to the social media company's server. The server processes your request, retrieves your account information, and sends it back to your phone. Security layers. Now, how does the internet stay secure? That's where encryption protocols like HTTPS come in. The S in HTTPS stands for secure, meaning the data exchange between your browser and the server is encrypted. This ensures that sensitive information, like passwords or credit card numbers, is protected from hackers. Why this matters for programmers? As a programmer, understanding these mechanics is essential. Whether you're building a website, an API, or a mobile app, you'll be working with HTTP requests, handling data packets, or using DNS. You might also set up servers or configure IP addresses. For example, if you create a web app, you'll need to know how your client-side code, HTML, CSS, JavaScript, communicates with the server-side code, written in Python, Node.js, etc. If you're debugging network issues, knowing about IP addresses and packet switching will help you pinpoint problems. So there you have it, a peek under the hood of the internet. It's all about devices communicating using protocols, sending and receiving data packets, and working together seamlessly. The internet might seem complex, but with this foundation, you're well on your way to mastering it as a programmer. Now that you know all about the internet, the next logical stop is a browser. Understanding how a browser works is a great place to start for future programmers. Browsers are the tools we use every day to explore the internet. But what's happening behind the scenes when you open a website? Let's break it down step by step. A browser like Chrome, Firefox, or Safari is an application that helps you access and interact with websites. When you type a web address like www.example.com into the browser's address bar, it sets off a process to fetch and display the web page. Think of it as a translator that takes code from the internet, HTML, CSS, and JavaScript, and turns it into the interactive pages you see. The following is the step-by-step process DNS lookup. When you hit enter, the browser first connects to a DNS server to find the IP address of the website. This is like looking up a phone number to call someone, sending a request. Once the browser has the IP address, it sends an HTTP or HTTPS request to the server where the website is hosted. It's like saying, "Hey server, please send me the files for this website." Receiving the response. The server responds by sending back the files for the website. These files typically include HTML, the structure of the page, CSS, the styles like colors and layouts, JavaScript, the functionality like animations or buttons. Rendering the page, the browser takes these files and starts rendering the web page. This means it builds the structure using HTML, applies styles using CSS, executes scripts with JavaScript to make the page interactive. Browsers use special engines to do all this work. For example, Chrome uses the Blink engine and Firefox uses Gecko. These engines interpret the code and turn it into the visuals and interactions you see. To give you an example, think of your browser as a chef in a kitchen. The HTML is the recipe. It tells the chef what to prepare. The CSS is like plating instructions. It makes the dish look appealing. The JavaScript adds flavor or special effects. It makes the dish more enjoyable. The chef takes all these ingredients and prepares a delicious dish, or in this case, a functional web page. And there you have it. A browser is your gateway to the web, fetching, interpreting, and displaying content so you can interact with it. Now that you know how it works, imagine the power you'll have when you learn to write the code that browsers render. What is a website and how does it work? Let's break it down step by step so you can get a clear picture of how websites function behind the scenes. A website is essentially a collection of web pages, which are documents written in HTML, hypertext markup language, combined with CSS, cascading style sheets, for design and JavaScript for interactivity. Think of a website like a digital book where each page can be linked to others, offering information, services, or entertainment. How does a website work? The server side, hosting. Websites live on servers, which are computers always connected to the internet, waiting for requests. Your website's files, HTML, CSS, JavaScript, images, etc., are stored here. Backend. This is where server-side languages like PHP, Python, Ruby, or Node.js come into play. They handle database interaction, If your site needs to store or retrieve data, like for user accounts or blog posts, the backend communicates with databases. Dynamic content, generating pages on the fly based on user input or data from the database. We will look into them in detail the next section. The client side, your browser. Request. When you type a URL or click a link, your browser sends an HTTP request to the server hosting the website. Response. The server responds by sending back the requested files. Here's what happens next. HTML parsing. Your browser reads the HTML, which outlines the structure of the page. It builds the DOM, Document Object Model, a tree-like structure of all the page's elements. CSS application. CSS dictates how these elements should look, applying styles like colors, fonts, and layout. JavaScript execution. JavaScript adds functionality, making the page interactive. It can modify the DOM, react to user actions, or fetch more data from the server without reloading the page. Interactivity and user experience. Forms. When you fill out a form, JavaScript can validate your input on the client side before sending it to the server for processing. Ajax allows parts of the page to update without a full page reload, enhancing user experience by making everything feel faster and more dynamic. For you as a programmer, understanding these components means writing cleaner HTML for structure, crafting CSS for beautiful designs, using JavaScript for rich interactions, maybe even diving into back-end development to see how data is managed and served. Every time you visit a website, you're seeing the result of these technologies harmoniously working together. As you learn to program, you'll start to see not just the finished product, but the intricate dance of code behind every click. Now that you are familiar with many concepts related to computers and internet, you are ready to learn about the core concepts you need to know before you start programming.